So this is 2.2b is in beta, and we are on page 108. This is fitting lines to data points and linear regression. And linear regression is the procedure in order to find the line that is the best fit. So linear regression is also called the least squares method, and that's what I'm going to go over with you for just a minute. I'm not going to go into a lot of detail on how to find this. This is more calculus, but I do want you to be at least familiar with the linear regression or least squares line. So let's look at that just for a short period of time and then go on. Okay, so what we have here is two different graphs. This is from the example we did earlier, example 2, population of females under the age of 18. And we have two lines. We have this line right here and this line right here. Obviously, this line looks like the line of best fit compared to this line because the distance from here to here is quite substantial compared to, it pretty much being on the line for that one. So sometimes it's not so obvious. I tried to use this one because it is very obvious, and we're going to use linear regression in order to make that determination mathematically on which of the two lines are the best fit. Now again, this is an obvious best fit line here compared to here, but I wanted it to be obvious so you could get an idea of what's going on here. Alright, so this is how it works. We are going to look at the difference between the point and the line that we drew. We're going to look at that distance right there. So what we're going to do is we're going to take the y value of this point minus the y value of this point. Okay, and we're going to get a number. And then we're going to square that number. Okay, so let's just kind of make up some here. And let's get this to be bigger. Let's just say, for instance, that the distance here is 4, 3, 2, 1, 1. And let's just look at these 5 numbers right there. All right, so the linear regression says, or the least squares line says, in order to determine if that's the line is best fit, we take each of the numbers and square it, add the other number, add the next one, add the next one, and add the next one. Okay, so again, these numbers, 1, 1, 2, 3, 4, is the distance between here and here. So let's say that that D9, we went up from the x-axis, and I'll put this in yellow, and D9 is up 43, okay? And let's say that this point here is at 39. So that's how I got the 4, is I took the difference between here, the y value here, 43, minus the 39, which gave me 4. And then I forgot to square it. So now I add all these up. And I get 25, 29, 30, 31. I get 31. Okay? Now let's look at this other one down here. Now when I look at this one, and I'm going to look at the same points, which is 9, 8, 7, 6, and 5. And this one, let's say, is 1, 1. That's right on, so the difference between that, the point and the line, is 0. The distance there is pretty much 0, and the distance there is pretty much 0. So because these points basically are on the line, the difference between where the line is and where the point is 0. So now let's take those, square them, and add them. Obviously. And that gives us 2. So that number is 2. And this number up here on this other one we came up with was 31. Okay, the smallest answer that you get is the best fit line. Now, normally when you do this, you're going to get lines that are a lot smaller than this. You're going to get decimals. Oftentimes you'll get down into like 0.015 or something like that. And again, as you get into this, you'll be using graphing calculators and spreadsheets like Excel. And this is more of calculus, but I did want to go into this since the book just kind of highlights it a little bit. I don't think the book is going to give you any problems in the homework on this kind of stuff, but I did want to go over it and just get you somewhat familiar with it. All right, so the next few pages has to do with using your graphing calculator in order to solve these problems as far as being able to do scatter graphs as well as look at the data, be able to interpret the data, and be able to graph the points and the best fit line and all that kind of information. So go ahead and look at that information, but I'm going to jump down to examples 3 and 4 just for a minute, and I'm not going to go into those because again, these are done using graphing calculators, and you can read how to input the values into your graphing calculator looking at the solutions for examples 3 and 4. It would be too difficult for me to try to explain how to put all this information into your calculator on a video like this. So just follow the instructions there as far as being able to put the information in a graphing calculator. So that's, again, examples 3 and 4. And we're going to jump to page 115 on applying models and just look at two terms, interpolation and extrapolation. So just real quickly, interpolation basically means that we are trying to find out some information between the values that they've given us. So, for example, if I've got a graph here and I have a line and I know what's going on here and I know what's going on here, but I want to find out what's going on here, that's called interpolation. Okay? Because I am looking between two values that I already know in order to find a value between them. Okay, so extrapolation, which has the word extra, which means beyond. Okay, so beyond what we've got, this is more of a prediction. And what we're doing here is we are trying to find out outside of the input data points. So like here, this data point and this data point, we're going to go outside here and try to figure out what's going on up here, outside of our 2 points, or someplace down here. So that's extrapolation, as we're trying to predict what may happen after we pass our points that were given in the graph. Okay, so interpolation and extrapolation. And one of the other things there's talking about in applying models, bottom of page 115, is when you're given a year that you're looking at data, are we talking about in January of that year, in June, in October, in December? Okay, so for lack of a better way of doing this, in order to be consistent all the way through the book, a point on input that has to do with a year. So if I'm talking about 1999, I am talking about at the end of 1999. Okay, and this is also the beginning of year 2000. Okay, so we can't be going back and forth and saying we're talking in this particular instance, the end of 1999, and in this particular instance, we're talking about the beginning of 2000. That's not giving us consistency. So if we just say at the end of every year that we put down on our x-axis when we're modeling this stuff, it's going to be the end of the year. So that is it for 2.2, two short videos, and not a whole lot going on in this section. I'm not expecting you to really get the graphing down perfectly because we will be doing graphing throughout the book, but just wanted to give you a little bit of a taste of the graphing models that we'll be looking at.